short contribution of the whole colloquium.
You don't mind if, I don't see very well and I don't want to fall down while talking. Of course, this first slide is already wrong because I should have added at least Philippe Bois and Massimo Cuomo, but you will see later why. I belong to a part of Italy which is called Magna Graecia. So there is a theory which claims that this Metrodoron was the first one who formulated the principle of virtual works, but this is a theory. I want to talk about a conceptual straitjacket. I like very much the French word, camisole, okay? And in Italian it is called camicia di forza. You are tied like this and you cannot move. This straitjacket was prepared by Cauchy, and I am very happy that Giampiero Del Piero wrote a date, 1827. Remember this date. So let us talk quickly what has been done by Gabriel Piola. Of course, my friend Gerard will be the first one to whom I will send a copy of the translated works of Piola from Italian to English. With the original Italian without any change. And Giampiero already accepted to check if my translation is good. Okay? So, sorry? I wrote it in a mail, so I can show you the mail. So you start with the internal power, which Piola wrote in the form 1 in the Lagrangian configuration. Then he integrates by parts and he gets the second formula. Then he says, what is the class of external actions which can be sustained by the bodies having the power given by one? You look and you say, you need a Bx, a volume force, and a Fx, a surface force. In 1823, you find this in the works of Gabriel Piola. Gabriel Piola had only one guilty. He wrote in Italian. Okay? Cauchy goes to Turin because he's chased by France, and then he takes this expression, the last one, and he manipulates it. He introduces contact actions, Cauchy postulate, balance of force and momentum, and then proves, this is wrong, the existence of stress by means of well-known tetrahedron argument. Okay? So he gets, as a result, what was Piola's starting point. Now, the two approaches may be considered as equivalent, in a sense. Okay? However, Cauchy postulation is not suitable for generalizations. Cauchy postulation is Eulerian. Everybody remembers painfully how he needed to fight against Piola transformation. You know, the original order of ideas sometimes remains hidden, to write everything in the referential configuration. Moreover, the concept of contact force cannot be easily adapted to more complicated continua. Balance of force and torques cannot be easily generalized, and it is very difficult to generalize the expression 1 for internal power. There is a paper by Dunn and Serrin in which painfully they introduce an extra flux of sounding for finding a reasonable generalization to Cauchy. And I remember that when I started working with Pierre Sepechet, now more than 22 years ago, we spent weeks trying to understand what was written in that paper. Now we have to invent metamaterials. Metamaterials are not materials you find in the street. Metamaterials are conceived like the pantographic structure presented by Pierre this morning for doing something. Okay. They are obtained by suitably assembling multiple individual elements constructed with already available microscopic materials, but they are arranged in clever ways. Okay? So not only a metamaterial depends on the constituent materials' properties, but most important, their property depends on the way in which you assembled this material. And Pierce gave you, in my opinion, an interesting example of this. This picture is beautiful. This is an optical metamaterial, but I wanted to show you. Okay. So, actually, and this is very important, the third point, microstructures which present high constant in microscopic properties, and Marcus presented a material, voids and solid. So higher contrast than this one you cannot get. So once homogenized, this is a beautiful paper which Pierre didn't want to write with me, but with Catherine Pirelli. He proved, and also Kamar Eddin, he proved in a very elegant mathematical way that if you have Cauchy continua at the beginning and you mix them in a clever way, as a final result you get higher gradient continua. Okay, so you have a representative elementary volume, you send it the size to 0, and you manage to get exotic materials. Then I fell in a pitfall. I believed that I could easily describe. I thought when Philippe Bois spoke to me, I said, okay, I will do it in 3 days and he will be happy. It is now more than 1 year that this material used in composites is behaving in a very strange way. And Angela Amadeo will show you how we managed to handle this with second gradient models. Then I asked to Massimo Cuomo and Leopoldo Greco to do a numerical simulation with this metamaterial, which is constituted in a very similar way to the metamaterial shown you by Pierre Sepechet, and you can see boundary layers arising everywhere. And up to now, we have no idea how to model this discrete system with a continuum model. I am afraid that even nth gradient continua are not enough. This is a model starting with a discrete structure with beams and plate elements. Okay, so this animal behaves in a very strange way, and this is not Philippe Bois composite fiber reinforcement, but it behaves in a similar way. It behaves in a much worse. Okay. This is the metamaterial you already have seen. This is a metamaterial in which, look, it is very nice. This structure, you pull this way, and you have a negative Poisson ratio. Okay. This metamaterial is a solid which is not able to exert shear. So it is a fluid solid, a solid fluid, I don't know. So if you are looking for the correct conceptual frame, I think that stress is less fundamental than the concept of deformation and dissipated energies. That one has to get rid of the straitjacket of finding everything which is important, then postulate balance of everything which is important, plus constitutive equations. One has to avoid useless proliferation of principles, which is criticized by Piola. I think this is the most controversial statement. The modern epigoness of Poisson and Navier must be avoided. Remember that Rivlin, Midlin, and Germain violently attacked the point of view of Trussell. In my opinion, Trussell was like Homer. Sometimes he was sleeping. Lagrange postulation of mechanics, I'm sorry, we have translated in English the last two of these books. Those who can read Italian could be excited by this elegance. Since Lagrange managed to reduce all the questions of rational mechanics to the calculus of variations, the decision of insisting to avoid its use is similar to wish to behave as those who, being involved in the researches in higher geometry, instead of trying to use the formulas taken from integral and differential calculus, stubbornly persist in using, in a pedestrian way, synthetic methods. Nobody now is using a Euclid network of lines. We use Cartesian geometry. So this is the idea of Piola. And in the book of Piola, you find Formula 2. Of course, he didn't know tensors, so he wrote this component-wise. Internal power is not the simple expression given by Cauchy. It is this sum where T lambdas are first stress, second stress, and stress. This is not only my rediscovery. Green and Rivlin called these animals these lambda contravariant tensors, lambda order multipolar stress. Okay, I was obliged to study Schwarz. There is a C lacking there. Schwarz theorem in the theory of distribution. 2 is the most general linear continuous functional in the space of C infinity function with support, compact support, and with Fréchet matrix. So this animal too is very general. Okay, I will not bore with the integration by parts details, but I will try to tell you shortly the result we got. You integrate by parts and you get the external power compatible with this internal nth gradient continuum. You get FB0. This is the dual of velocity. This is a force per unit volume. Then you get F boundary of B0 on the edge, on the boundary of B. So you get a force per unit area. Then your integration by parts left you some normal gradients. So the dual of the Lth transversal gradient you can call, following middling, L force. So it is a generalization of force. But your integration by parts gives you a force per unit edge, F boundary of B0, J force per unit edge. Then you integrate by parts another time. And you go on the wedges. On a wedge, everything is orthogonal. So you get forces or J forces on the wedge. Now, which is the problem of Cauchy? To find a way for representing these F's in terms of the previously introduced T lambda. The first representation you find written in Piola 1848. So this formula is already available there. The edge force, of course, I was a little bit provocative, so I will go ahead. I need a projector. Given a tensor, P of this tensor is another tensor which is constructed in this way, where P, the normal P, is the projection on the tangent space of the manifold M you are considering, and Q is the projection in the orthogonal space. So if you have a surface, P is the projection along the tangent plane, and Q is the projection along the normal. If your manifold M is a line, a curve, then P is the projection along the tangent line, and Q is the projection in the orthogonal plane. C alpha n are the binomial coefficients. So you take T, you project this way. You can calculate the surface or line divergence alpha times, and you get an operator. Now let's go back. So the force per unit area is T boundary of BL, which is given in this way. Then, this is the stress. This is, we have to call it stress. Then you have stress per unit line on the edge, which you define in this way in terms of the previous stress you introduced. I want to call this stress for a suggestion given to me by Giampiero. This is the dual of gradient of velocity on the surface, while force is the dual of velocity or transversal gradient of velocity. Okay, then painfully you construct with iterative functions the forces in terms of the T stresses and the shape operators of surfaces and curves. It is difficult to understand in these involved formulas. What you have is that in nth gradient continua, the force per unit line depends on the nth minus 1 gradient of the normal of any Cauchy cut. This is what, not only on a poor edge, and my friend Ali Javili knows because we did a painful calculation for this, on an edge you have the Freinet basis along the curve, plus the projection of normals of both faces which are concurring in this edge. So the shape of a Cauchy cut is very complicated, and contact actions depend on this shape in this complicated way. So it could be very interesting. These are the final representation formulas. It could be very interesting to apply these formulas. When I present this result, somebody, by the way, I got a review, for a paper, 2 reviews. One reviewer said I am too mathematical, and the other review said I'm not enough mathematical. This is a very good sign, in my opinion. In Greek, mathemata means those things which, for being understood, need to be studied for a lot of time. Look how beautiful is Greek. Mathemata, this means this. So, Nicolaus Copernicus, when criticized because he was using too much mathematics, answered shortly, before talking, please, try to study a little bit. In France, there is this beautiful statue, Musée d'Orsay. La nature se dévoilant à la science. I think that this beautiful girl you will see only if you find a least action principle. So it is useful for... I want to conclude with this. I have ready another work. This is true also. With Pierre Sepecher, we have a paper already written, we have to complete it, which is not short, this is also true, and which will continue the present one. And I strongly desire to be able to produce ulterior factual evidence of the stated assertion. But whenever I will be able to conclude my work, and no matter how successful will be my own efforts, I am strongly persuaded that time will give reason to the words with which I started this memoir. Thanks a lot.
Thank you very much, Francesco. Okay, Elena.
I like very much your presentation, but I think I disagree with the conclusion that in Cauchy Continua we cannot help with the materials. For example, there is no program in Cauchy formulation to consider the Castera continuum. And if we consider special type of Castera continuum, reduced Castera continuum, where nothing works on the gradient of the angular velocity, then we will have a metamaterial.
Okay, I think that I was too quick. This velocity here is not necessarily the standard velocity, the one which is the variation in time of the position. This could be an element of the tangent bundle of a manifold where your state fields have values. In other words, in this V you can have time derivative of placement, angular velocities, velocity of directors, velocity of tensors. This summation is not involved in the integration by parts. So this is a general structure which, so Castera continua are first gradient continua in which the kinematical fields are positions and rotations.
Yes.
But you can have second gradient Castera continua.
So I have something more complex.
Yeah, and it falls in this.
Could I ask you a question about Viola in particular?
Yes.
On your first slide, what did Viola see?
Sorry, I have to switch on the light, otherwise I don't see anybody.
I don't wish to start the discussion here, it's not the case.
No.
But I have to warn the audience about a couple things you say, just not to take them in. First of all, this expression of which you showed holds most for elastic bodies, because not only we but everybody else has much more complicated expressions of internal power involving other variables. So most of this is an elastic analysis. Second, it is very fun. You started from the internal power and then making integrations by part, you find that these forces at the corners. And this is technically better, I would say, but what comes up is a model in which you, as a button, can apply the concentrated forces only at the corner. And one wonders why not in any other form.
Piola answered to you. Why you cannot apply a shear force on the boundary of an Euler fluid?
I don't know this, but if I am free to apply a force at the corner, you see why I cannot apply it with the...
Okay, we can discuss.